All right, this is a 4-part video that will review the 36 5th grade math benchmarks for the FAST assessment. This specific video includes 10 questions that will review the category, number sense, and operations. Each question will have a similar format to this. I will read the question, then bring out this blue star. This is a recommended reminder to pause the video so you can work out the problem. Then press play to see if you got the correct answer. So let's get started. Which statement correctly compares 34 thousandths and 34? Is it A, 34 thousandths is 10 times the value of 34? I know in math, the word is can be represented by the equal sign. So 34 thousandths is equal to 10 times 34, which is equal to 340. Because if I multiply by 10, I know the decimal place goes to the right one place value because it's 10 times the value of. So 34 thousandths is equal to 340. No. 34 thousandths is 1/10 the value of 34. So 1/10 the value of 34 is equal to 3.4. I'm moving that decimal place 1 to the left because it's 1/10 of. Those are not equal, so no. 34 thousandths is 100th the value of 34. 100th the value of 34. This time I'm moving my decimal place over 2 times to the left because it's 1/10, 1/10, which is equal to 100th. Those are not equal. D, 34 thousandths is 1,000th the value of 34. This I'm going to multiply 34 by 1,000th. And this time you're moving the decimal place 3 times over, 1, 2, 3 to the left because it's 1/10, 1/10, 1/10, which is equal to 1,000th. And those two decimals are equal. So D was the correct answer. All right, question number 2. Write the following number in word form and expanded form. All right, so in word form, I would write it as I would read it. So 300, 300, 320, and the decimal place can be written as the word and, 320 and 745, last place value, thousandths, and 745, final place values in the thousands, so it'd be thousandths. Word form, check. Expanded form, I like to go place value by place value. So the 3 is in the hundreds place, so it's 3 times 100. Plus 2 is in the tens place, 2 times 10. Plus, there's no digit above 0 in the 1, so you just leave that as is. 7 in the tenths place, so plus 7 times 1/10. Plus 4 in the hundredths place, so 4 times 100th. And then 5 in the thousandths place, so 5 times 1,000th. So we have word form and expanded form. All right, question number 3. Select all the ways to represent 82 and 33 thousandths. All right, is it A, 8 tens, 8 in the tens place, 2 ones, 3 hundredths, I'm going to skip one place value because there's nothing in the tenths, and 3/1000ths. Those two decimals are the same. So A is one of the correct answers. B, 8/10, tens place, 2 ones, ones place, 3/10, tenths place, 3/100ths. Look at those two. No, they are not the same. 8/10, tens place, 2 ones, 33/1000ths. So nothing in the tenths, but 33/1000ths. Those two are the same. So C is another correct answer. D, 82 ones, 82 ones, 33/100ths, 33/100ths. Those are not the same. And then E, 82 ones, 82 ones, 33/1000ths, 33/1000ths. Those are the same. So the correct answers were A, C, and E. All right, question number 4. Order the following decimals from least to greatest. All right, I like to rewrite my decimals when I'm ordering them or comparing them in fractional form because it helps me understand their value as I compare them. So 3 and 9/100ths, 30 and 9/10ths, 3 and 9/1000ths, 3 and 9/10ths, and 30 and 9/100ths. So right off the bat, I can see 3, 3, 3. So they're the smallest values. And then looking at the fractional part, 9/100ths, 9/1000ths, and 9/10ths. I know that 9/1000ths is the smallest value. So that is going to go first, 3 and 9/1000ths, but I'll write it as a decimal. And then looking at those threes again, 3 and 9/100ths, 3 and 9/10ths. I know 9/100ths is less than 9/10ths. So 3 and 9/100ths. The next 3, 3 and 9/10ths. And then looking at the two 30s, 30 and 9/10ths or 9/100ths. I know hundredths is less. Oops. And then 30 and 9/10ths. So 3 and 9/1000ths, 3 and 9/100ths, 3 and 9/10ths, 30 and 9/100ths, 30 and 9/10ths. All right, question number 5. Round each decimal to the nearest whole and tenth. All right, we'll start by looking at each decimal and rounding each of them to the whole. So many ways to round using a number line. Because this is a test format and it's a little bit of a smaller space, I'm just going to use kind of a more old-fashioned way. So I'm going to underline the place value I'm rounding to, so it's the whole. So underline the whole, which is the ones place. I'm going to look to the right. Remember, rounding up is 5 or more. Rounding down is 4 or less. So whole number 2, I'm going to look to the right. It is 0, so it's 4 or less. So it stays as 2. So it stays as 2. Two and 947,000ths. Underline the ones place, the whole number. Look to the right. It's 9. So 2 and 9. So it's going to be greater than 5. That means I'm going to round up to 3. 3 and 11/100ths. Look to the right. It's 1, 3.11, 3 and 11/100ths. It rounds down. It stays at 3. And then 3 and 908,000ths. Looking at 3, look to the right. It's much more closer to 4 because a 9, right, is greater than 5. So 3 is going to round up 3 and 908 thousandths is going to round up to 4. All right, let's look at the tenths place. So same decimals, 2 and 6 hundredths, but looking at the tenths place, look to the right. 6 hundredths is closer to 2 and 1/10 versus just 2, because 6 is greater than 5. Looking at the next one, the tenths place, look to the right. 4 is less than 5, so it's going to round down. Or stay the same at 2 and 9/10. 3 and 11 hundredths. Look at the tenths place, look to the right. It's 1, it's less than 4. It's going to stay at 3 and 1/10. And the last one is 3 and 908 thousandths. Looking at the 9 and the tenths place, look to the right. It's 0, so it's going to stay the same for the tenths place. So 3 and 9/10. All right, this is question number 6. Multiply 9,845 times 32. Many different ways you can solve this problem, but I'm just going to use the standard algorithm. So 9,845 times 32. 2 times 5 is 10. 0, regroup the 1. 4 times 2 is 8. Add 1 is 9. 2 times 8 is 16. 6, regroup the 1. And then 2 times 9 is 18 plus 1 is 19. 3 times 5 is 15. 5, regroup the 1. 3 times 4 is 12. Add 1 is 13. Regroup the 1. 3 times 8 is 24 plus 1 is 25. Regroup the 2. 3 times 9 is 27 plus 2 is 29. Add my two partial products. 0, 14, 4, regroup the 1. 10, 0, regroup the 1. 15, the 1. 10, 11, group the 1, and 2 plus 1 is 3. So it should have been 315,040. All right, this is question number 7. Divide 909 divided by 12. All right, again, many different ways you can solve for this. I'm going to use the area model. So 909 divided by 12. 12 groups of what can go into 909, or I can take away from. So I know 12 times 10 is 120, and 12 times 100 is 1,200, which is way more than 909. So I'm going to go less or in between 10 and 100. I know that 12 times 7 is 84. So instead of doing 7, I'm going to do 70. So 70 groups of 12, which is 840. Subtract. 69 is remaining. Create another area here. 12 groups of what can go, it can be taken away from 69 but not going over. So I know 12 times 5 is 60. So I'm going to take that away from the 69, which is a remainder of 9. 9 is less than 12, so I know I can't take out any more with whole numbers. So I'm going to add the two partial quotients, so 75. And then my remainder whole number is going to be the numerator, and my divisor will be the denominator. So my final answer is 75 and 9/12. All right, this is question 8. What is the sum of 5 4/10 and 3 602 thousandths? What is the difference of 4 1/10 and 2 78 hundredths? All right, so when we're working with decimals, most important thing when you're adding and subtracting is to line up your decimal. And by default, I always use the number, the decimal, which has more place values listed. So this number right here, so 3 and 602 thousandths will go on top for me. And then 5, make sure I line up my decimals, and 4/10ths. And I like to add on these invisible zeros, and it just helps me keep track of my place values. So sum means to add, right? So I'm going to add these two decimals. Looking at the thousandths place, 2, hundredths place, 0, tenths place, 10, but we're going to regroup that. And then 3 plus 5 is 8, plus 1 is 9. So the sum is 9 and 2 thousandths. All right, what is the difference? So difference means to subtract. So 4 and 1/10, subtract 2 and 78 hundredths. And again, I like to add my invisible 0 up here just to keep track of my place values. So just like regular subtraction, I have to regroup here. So I'm going to take from here and then regroup from here. So 10 minus 8 is 2 hundredths. 10 minus 7 is 3/10ths. Bring down my decimal, and then 3 minus 2 just wholes is 1. So the difference is 1 and 32 hundredths. Question number 9. What is the product of 24 and 81 hundredths? What is the quotient of 5 and 1/10 and 6 hundredths? All right, what is the product of 24 and 81 hundredths? So again, just a personal preference. Product is multiply. Personal preference, I like to, with decimals, keep the decimal with more place values on top, even though that's just kind of a holder. And then I multiply by 24. I'm just going to add a decimal there so you can see that's whole. It's a whole number. So 1 times 4 is 4. 8 times 4 is 32. Regroup the 3. And then my place value holder. 2 times 1 is 2. 2 times 8 is 16. I add these two in there. Sum is going to be over here just because of space. So 4, 4, 9, 1. And then I'm going to see in my decimals that I'm multiplying, the whole numbers, how many decimals was I using? So there's 1, 2, 1, 2. So it's 19 and 44 hundredths. 19.44 for the multiplication. What is the quotient? So I'm dividing, of 5 and 1/10 and 6 hundredths. So I'm going to use the area model. So 5 and 1/10 divided by 6 hundredths. So how many groups of 6 hundredths can go into 5 and 1/10? So I'm looking at this as like 6 and 51, and a multiple of 6 close to 51. So what I can think of right off the top of my head is 8. But I know 8 groups of 6 hundredths is equal to 48 hundredths, right? And that's way less than 5 and 1/10. So instead of doing 8, I'll do 80, which is equal to 4 and 8/10ths, or 4 and 80 hundredths. You can kind of see how it moved. So that's a good one. So I'm going to take out 80 groups of 6 hundredths, which is 4 and 8/10ths. And I'll have a remainder of 3/10ths. Bring that out over here. And I want to look at it as 30 hundredths, so I can kind of see how many groups of 6 hundredths can go into 30 hundredths. And that one's pretty easy. It's just 5, right? So 5 groups of 6 hundredths. 5 times 6 is 30. 30 hundredths. Subtract. Add my two partial quotients up here, which is equal to 85. which is the quotient of 5 and 1/10 and 6/100ths. All right, question 10, final question. Multiply and divide 24 and 5/10, 30 and 1/10 by times 1/10 times 100th divided by 1/10 divided by 100th. All right, so real quick, when you multiply by 1/10, the value is actually getting smaller, and you're moving the decimal place to the left, one place value, because each place value is either 10 times or 1/10 that. If you're multiplying by 100th, you're moving the decimal place over 2 times, because 1/10 times 1/10 is 100th. Now for 1/10, if you're dividing by 1/10, I like to think of it as how many groups of 1/10 go into that number. So you're going to move the decimal place over to the right this time, because if you think about it as like 1 divided by 1/10, how many groups of 1/10 can go into 1? It's 10, right? So it's actually times 10. So it's moving the decimal place to the right. Same thought process here. 1/10, 1/10. 1/10 times 1/10 is 100th. So you're dividing by 100th. So 24 and 5/10, 1/10 of that. Or sorry, 24 and 5/10, 1/10 of that is 2 and 40. Or excuse, yeah, 2 and 4500ths, because you moved it over one place to the left. 2 place values over is 245 thousandths. This time you're multiplying by 10, so 245, and multiplying by 100 is 2,450. And then 30 and 1/10 of that is 3 and 100th. 100th of that is 301 thousandths. And then how many groups of 1/10 are in 30.1? 301, because you're multiplying by 10 in essence. And then divided by 100th is 3,010. And that is it for number sense and operations.